Hey everyone, and welcome to section 8.6 on solving radical equations. I'm your host, Dr. Medwood. Let's get started. Alright, you probably figured this by now, but an equation in which the variable is in the radical symbol is called a radical equation. Something like that. The general approach here is not unlike other equations that we've solved in the past. Generally speaking, we want to get the radical isolated on one side of the equation. So if I did that here, I would add 9 to both sides. And then I undo the radical by squaring both sides. So we get that 5n minus 4 is equal to 9, or 5n equals 13, or n is equal to 13 over 5. Let's look at another one. So here we would be thinking to do the same thing. Get the radical on one side by itself. So we'd have 10z plus 1, and is equal to negative 2. Hold the phone. Don't get too excited, okay? Don't get carried away. We have a negative on the right-hand side of our equation. Well, that may not seem significant. The expression on the left-hand side is under a square root. If you recall, we can never take the square root of something and get something negative. So we can say right away, there's no solution. Sometimes it happens with radicals. All right, adding some more components now. We have p, the square root of p minus 1 plus 1 is equal to p. Again, we want to do the same thing that we were just doing. That is, we're going to isolate the radical expression. Subtract 1 from both sides. We'll get the square root of p minus 1 is equal to p minus 1. Now, I'll square both sides. On the left-hand side, I get p minus 1. On the right-hand side, be careful, please. Please. We have p minus 1 equals p minus 1 times p minus 1. Let's FOIL. All told, I get p squared minus 2p plus 1. I know that from our special form, right? Our special products. Now I just want to solve. So I'll get everything on one side of the equation. I'll have to add 1. So I have p equals p squared minus 2p plus 2, and then subtract a p. So really we have 0 equals p squared minus 3p plus 2. And I got a factor. This one's actually pretty easy compared to some of the other ones we did. Now we're using the zero product property. So p is equal to 1 or 2. Now, checking your answers in a radical equation is actually particularly important because whenever you square both sides of an equation, you run the risk of introducing more extraneous solutions. So let's check. P equals 1. Plus 1 equals 1. 0 plus 1 equals 1. All right, that's fine. What about p equals 2? Okay, so it checks out. And our solutions really are 1 and 2. All right, more of the same stuff. So I have square root of 4x minus 3 plus 8 equals 5. Let's get the radical on one side by itself. So I would subtract 8. Now I have the square root of 4x minus 3 equals 5 minus 8 with negative 3. Aha! And I know a square root cannot be equal to a negative number. So I've got no solution. Oh, okay. Now I have fractional exponents, which is secretly still a radical equation. So I want to isolate again. Subtract 3 from both sides. I'll have 3x minus 2 raised to the 1/4 power is equal to 2. So I'm going to raise both sides to the 4th power. So I'll have 3x minus 2 is equal to 2 to the 4th, which is 16. Subtract 2 from, we're going to add 2 to both sides to get 3x alone. And then x is equal to 6. Again, we want to check. So whenever we do this practice of raising one side to a power, we run the risk of creating additional solutions. It's just a good idea to check. So let's check. Plug in x equals 6. So I have 3 times 6 minus 2 raised to the 1/4 power plus 3. And I want to know, does that equal 5? 18 minus 2 raised to the 1/4 power plus 3 equals 5. 16 to the 1/4 power plus 3. 2 plus 3 equals 5. Okay, so we're good. And let's see, I think I got one more in me. Here's our last example. We have radicals on both sides of the equations, really awful looking. Since I have one side already isolated for a radical, I'm going to square both sides straight away. So the right-hand side just becomes 4t plus 1. And we want to be careful here with the left-hand side. We actually have to FOIL this nonsense. So that can be kind of intimidating. We'll just think of it in these terms. So I'm doing something like a plus 3 times a plus 3. That's a little bit easier to swallow. Okay, FOIL. So I'll have a squared plus 3a plus 3a plus 9. In other words, I'll have a squared plus 6a plus 9. And that a is really our square root of t minus 2. So let's go ahead and put that in. So here we get t minus 2 plus 6 root t minus 2 plus 9 equals 4t plus 1. Then I'm going to simplify a little bit, so I would have t plus 7 plus 6 times the square root of t minus 2 equals 4t plus 1. Goodness gracious, this is really awful. I still have a radical, so I gotta isolate again. So move the t and the 7 over. I got 6 times the square root of t minus 2. This is equal to 3t minus 6. Alright, I don't actually have to divide out that 6. I can just square both sides. 36 times t minus 2 gets rid of the square root equals 3t minus 6 times 3t minus 6. Got a FOIL again. And here we have to distribute. So we get 36t minus 72. And this is equal to 9t squared minus 18t minus 18t plus 36. 36t minus 72 is equal to 9t squared minus 36t plus 36. Oh my god, are we done with this problem yet? Now I need to get all the variables on one side. So let's see, I'll add 72. I'm going to subtract 36t. Okay. I have to solve this creature. Luckily, there's a common factor of 9, which makes our life so much easier. In fact, we can divide it out if we want to. So we have 0 equals t squared minus 8t plus 12. That guy factors nicely. Using my zero product property, I get t is equal to 2 and t is equal to 6. I'm sorry to say this, but we're not done quite yet. We have to check the solutions, make sure everything is all good. So for checking, I'm going to plug 2 into the original equation. Get 3 is equal to square root of 9. Yes, so that one works. And then how about 6? I have the square root of 6 minus 2 plus 3 equals the square root of 4 times 6 plus 1. And I get that it checks out. So my final answers are 2 and 6. Whew. Pat yourself on the back if you're still here. That was pretty intense. You know what? Reward yourself. Have a treat. Crack open a nice age-appropriate beverage. And just relax a little bit. That about does it here for solving these equations. To close out Chapter 8, we're going to be looking at radical functions.